Hey everybody, we are going to keep rolling along here on the factor train. Hopefully greatest common factor stuff made sense to you guys. You guys got to practice with that homework last night. I'm going to check that out when you guys turn it in. But we're going to talk about factoring trinomials into binomials. So this is one of those things that's just like slope-intercept form, stuff like that, never going away. Solving two-step equations, never going away. All right, all that stuff is very much stuff you're going to use forever. So is factoring. You're going to factor these a lot. So let's start off, not too bad here. Let's go x squared plus 9x plus 8. Okay? Now, definitely, just by looking, the very first thing that you always check is, does it have a GCF? If it has a greatest common factor, then we're going to factor that out to start with. Okay? But as you can see, they don't have anything in common with all three terms. So, no greatest common factor, sweet. So you think, all right, maybe it's in factored form. Well, what's interesting is we can actually factor this even more. And this is where this kind of gets tricky, okay? So, if we call this standard form, right, these coefficients here typically are A, we call this one B, and we call this C. When A is 1, there's no number in front of x squared, just a 1. This is the most general form of trinomial factoring. And all of the ones we're going to talk about today are going to be in the form where there's nothing in front of x squared. So if you have something in front of x squared, it probably has the greatest common factor, and you should take that out to start with. Now, in order to factor this further, we need to do something with this B and the C. So we need two numbers. These two numbers are going to be important with B and C. We need them to multiply to equal C, and we need them to add to get you B. So every time that we're doing trinomial factoring, we're going to look at these three terms, and we're looking at what numbers multiply to get you 8 in this case, but add to get you 9. So there's a lot of ways people do this. You can make a table of values and look at everything that multiplies to give you 8, right? So there's 4 and 2, there's 8 and 1. That's pretty much it, right? Or you can just do this part, like go through your factors. You can do it that way. I've seen this thing people do where they say multiply to give you 8, add to give you 9, and then you can write your numbers here, 8 and 1. They multiply to give you 8, they add to give you 9. Whatever works for you. But you need to figure out that 9 and 8, or 8 and 1, multiply to give you 8, and they add to give you 9. Now, is there a really good way to do this and have you know? This is like the puzzle part of this. You're just going to have to work, especially if you're not great with number sense and your factors and your multiples. This might be rough. You can use your calculators, right? Sometimes this number is a lot bigger than 8, and there's a lot of factors that it could be. So you just kind of have to kind of, I don't want to say guess and check, but you can divide and see what turns out evenly and go from there. So here's what this is going to look like. We figured out that 8 and 1 multiply to give me 8 and add to give me 9. So what I can do is I can break this into two binomials. They're both going to have an x term, because this is just x squared. And then our factors are going to go here. And then the last thing you need to do is you need to look at the signs. So they multiply to give you positive 8. So that means my signs have to be the same, right? If you're multiplying to get a positive, they're either both plus or they're both minuses. And then over here, they add to give you positive 9. Well, that's going to have to be positive, positive. Because if you look at what happens here, if I redistribute, x times x is x squared. X times 8 is, let's do it this way, 8x. 1 times x is 1x. And 1 times 8 is 8. That's where this is coming from, because we can add our like terms together. And you can see we get back to the number we started with when I multiply them through. So I know that those are both factors. And if I multiply x plus 1 times x plus 8, we're going to get back x squared plus 9x plus 8. So it's a lot harder than doing the GCF way. But we're breaking it into two pieces. Then if we multiply them together, they're going to give us that trinomial. Let's do some more practice, shall we? The more of these you do, obviously the better it's going to get. But that is completely up to you, because I know it can be rough. It can be rough for sure. How about (2x squared) plus 10x minus 12. So the first thing I always check is, does it have a GCF? Well, if you notice, in this case, it actually does, right? Because 2 is a common factor in all of those. So I'm going to pull a 2 out first. So I pull the 2 out. That's going to leave me with just x squared plus 5x minus 6. Now, yesterday we could have said, now we're done, but now we know about trinomial factoring. So I'm going to check this one. Is there any numbers I know that'll multiply to give me negative 6, but add to give me 5? Well, not many things multiply to give me negative 6, right? Is it 2 and 3? 2 times 3 is 6. But if it's negative 6, one of them has to be negative. And 2 times negative 3 is not, or 2 plus negative 3 is not going to get you 5. Or 3 plus negative 2 is not going to get you 5. So that's not going to work. What about 6 and 1? One of them has to be negative, right? Well, let's see. If I add them, the bigger number has to be positive because I end with a positive here. So here's where my signs come into play. It's really interesting how this works with multiplication and addition. That's usually the trick that people have to figure out. So I know that one of my factors is going to be 6, positive 6. The other one is going to be negative 1. Because 6 times negative 1 is negative 6. But if I look at my middle terms, 6x and negative 1x would add to give me 5x. So this one, the factored form, is going to look like this. 2 out in front times x plus 6 times x minus 1. I hope you're not panicking at home because you're like, what is he doing up there? I know that this is kind of a trickster. It's just going to be something that you're going to have to get better at, okay? So let's try. How about x squared minus 10x plus 21. Okay, so we got this trinomial. First thing you're going to check, does it have a greatest common factor? I don't think so, because we just have x squared, nothing else going on, no greatest common factor. So then I look at my terms. Here's my b is negative 10. So I want something that's going to add to give me negative 10, but multiply to give me 21. Well, I don't know about you guys, but multiply to give me 21 makes me think 7 and 3. They multiply to give me 21. Do they add to give me negative 10? Well, depends on their signs, right? In order for it to get to negative 10, I think they would both have to be negative, right? Negative 7 plus negative 3 is negative 10. Negative 7 times negative 3 is going to give you positive 21. So those look good. So we're going to break this down. X minus 7 and x minus 3. So those two binomials, negative 7 times negative 3 is going to give you 21. If we look at the middle terms, negative 7x, negative 3x, you add them, you get negative 10x. Yeah, cool. Again, if you need help, if you are stuck, if you are confused, I get it. Let me know. I would love to help you out. You just are going to have to let me know that, okay? More for practice, for homework. We're not going to go to the next section. This is one of those things that we could probably spend a week on to make sure that you're ready to go, because you have to be really, really good at this part, all right? All right, try it out. Let me know how it goes.